Hey guys, for calculus, this is 5.2, integration of natural logarithms. Remember that these videos for chapter 5 are split. One playlist has the rules for derivatives, and this playlist is the rules for integration. Okay. In the videos in the playlist for derivatives, I go over some ln rules that we learned in algebra 2. Make sure to check that out if you see some things here that trip you up. Okay. So for starters, anytime we want to do the integral, and the rule that we need to pick is a natural logarithm, we want to have our eyes out for rational functions. Remember that a rational function is just a fraction function. And that's that, remember, if integration is the undoing of a derivative, the derivative of ln was u prime over u. So what we want to try and spot is the derivative of the denominator up top in the numerator. So the integral of u prime over u is ln of, and here we're adding these absolute value bars of u, and then don't forget your plus c. Okay, looking at this first example, you may feel like, okay, the derivative of x is not 2, but remember that with integrals we can rewrite and move that 2. Anytime we have a coefficient, we can move it out to the front and say 2 times the integral of 1 over x dx. And now I can see that the derivative of x is 1, so now I can spot that u prime over u. And then the antiderivative, I'm going to rewrite my 2. The antiderivative will simply be ln of absolute value of u, right, with whatever's in the denominator, plus c. This is one option of seeing your answer, okay? What the AP test likes to do is they like to mix in those ln rules in there. Now, remember that a logarithm rule, whether natural logarithm or regular, is that coefficients can be moved up to exponents. So another option would be ln of absolute value of x squared, moving that 2 up into the exponent. Those rules come from algebra 2, guys, okay? And lastly, because the AP Cal test really is just testing the fact that you are well-rounded in math, they will actually have in the multiple choice options ln of x squared plus c. Now, the reason why they like to do that is because no matter what value I put into x squared, whether I put a positive, let's say 4 squared, or a negative x squared, a squared will always make it positive. So because x squareds are always positive, you technically do not need those absolute value bars. So either of these two are correct, okay? But beware for things like this in a multiple choice question in the AP. Let's move on to the next thing we're going to be seeing. So let's read this statement here. If a fraction function, has a numerator with a degree greater than or equal to the degree in the denominator, long division will rewrite the function so that it can be solved using ln's. Okay, so a reminder that the degree of a term of a function is going to be based off of its highest exponent. As you can see in this question, the degree, the exponent, is equal in both the numerator and the denominator. As soon as I catch that, I know I'm going to long division. For long division, the denominator goes on the outside and the numerator goes on the inside of the box. Okay, you learned how to do this long division in Algebra 1, so I'm going to go over it briefly. When I'm working with long division, I just focus initially on the first term. How many times does x squared go into x squared? Well, it only goes in one time. It's all I need. So I'm going to multiply x squared times 1 is x squared. Anytime I'm working with long division, all of this needs to align. That means anytime I'm working with something to the second power, it goes in this column. First column goes in this column. And, sorry, first power. And anything that's just a constant goes in this column. So since I'm multiplying it by 1, okay, anything that's just a number goes in this column. Now, x squared plus 1 times 1 is just x squared plus 1. But I need to line up the x squared here and the 1 right here, okay? Now I am going to subtract this. So x squared minus x squared is 0, and 1 minus 1 is 0. And now I need to bring down anything that was left over. Okay, it's like saying x minus 0 is just going to be an x. Okay, so my answer here is a 1. And now the way that I write my remainder needs to be plus my remainder over what I was dividing by. Okay, so this is the answer to the division. Okay, not the answer to my integral. So now I'm going to rewrite my integral and say the integral of 1, and I can separate it. I could say 1 dx plus the integral of x over x squared plus 1 dx. Okay? So the antiderivative, the integral of 1 is simply x. That's easy. Then plus, here's where I'm going to do a little work. Okay? So if we treat this with u sub, let's check it out. My u is always going to be my more complicated part. So let's say u is x squared plus 1. My u prime is going to be 2x. Okay? Now notice that I am missing a 2. So in last chapter, we learned we can put that 2 in as long as we put the reciprocal in there as well. Okay? So now I'm working with half times the integral of u prime over u. And I can bring this x and this plus sign down. Okay? Now this should look familiar. We just talked about this rule. This is ln. So I'm going to say x plus half. And now this is ln, absolute value of u, plus c. And now for my next step, I'm just going to rewrite that u right back in there. So I'm going to have x plus half ln, absolute value of x squared plus 1 plus c. This is one option that you're going to see your answer as. Okay. Another option could be moving that 1/2 up. Remember, an exponent of 1/2 could be a square root. Okay. Just different options that you might see. So before we keep going, we need to talk about our trig integrals, because when we learned the reverse in chapter 4, we technically didn't get to see what the integral of these 4 were, okay? Because we didn't have a derivative rule for those. So we knew that the antiderivative of sine was a negative cosine, and the antiderivative of cosine was a positive sine. But now we move on to learn that tangent, the antiderivative, is a negative ln of absolute value of cosine of x plus c. Cotangent's antiderivative is a positive ln of absolute value of sine plus c. Secant, you can catch the patterns are very similar to the last one. It's ln absolute value of secant of x plus tangent of x, and then plus c. And cosecant is negative ln absolute value of cosecant of x plus cotangent of x plus c. And just like we talked about in chapter 4, for integrals, when the answer has a c, cosine, cosine, cosecant, cotangent, your answer also has a negative. Okay? I'm going to just show you really quick the proof of one of them, and then we'll move on. Tangent, if you don't have it memorized, we know that we can rewrite tangent as sine over cosine. Okay, and now if we see this as a u sub, we know that cosine's derivative is a negative sign. So if I say, okay, u is cosine, u prime is a negative sine of x, which means that I would just be missing a negative here, and I can place it as long as I place one on the outside, which leads me to write negative integral of u prime over u. And we know the answer to that, we'll bring our negative, is ln absolute value of u plus c. Put that u back in, and now we have negative ln absolute value, my u is cosine of x plus c. And there's the proof, just to see that the antiderivative tangent, negative ln cosine, absolute value of cosine, plus c. Let's move on to this next one that can be a little tricky, okay? I have the antiderivative, or the integral, of 1 over x times ln of x. Now, hopefully your mind, it might be looking a little tricky, but hopefully in your mind you know that ln of x and 1 over x have some sort of a relationship with each other, okay? I know that the derivative of ln of x is 1 over x. So if you catch that, then maybe you can say, maybe if I rewrite this of 1 over x times 1 over ln of x. And now I can say, all right, well, if I'm going to use some u-substitution, I already know that ln's derivative is 1 over x. Maybe that can help. Well, if I rewrite that here, I'd be saying the integral u prime is right here times 1 over ln of x is u, right? And if I rewrite that one more time and I multiply it, I could say this is u prime over u. I know the answer to that is ln absolute value of u plus c. And if I plug my u back in, I could say ln absolute value of ln of x, doesn't that look a little trippy, plus c. Okay, so when these questions start to get confusing, my advice to you is to try and simplify it by using u-substitution and try and catch if you can spot a derivative of the other, okay? For this next question, I want to show you one of the ways that the AP test likes to combine topics that you've learned not only in calculus, but in pre-calculus, and how they like to test those different concepts all within one question. So if I'm looking at this, if I even try to do a u-sub, because maybe that radical might make you think of a u-sub, my u would have to be the inside, 1 plus tangent squared, but then there's nothing on the outside to match up a u prime, okay? What I would like for your eyes to start getting better at is remembering some of those identities and rules from pre-cal chapter 4 and 5, okay? So hopefully your eyes start catching that there's an identity, a Pythagorean identity, that says that 1 plus tangent squared of x is equivalent to a secant squared of x. So I can rewrite this as the integral, instead of 1 plus tangent squared, as secant squared of x. And now that I only have one single term on the inside, I can cancel out the radical with the squared. I can't do that on the previous step, guys, because there are two terms. I can only cancel the radical with one single squared, not two different terms, okay? So now I'm doing the integral from 0 to pi over 4 of secant of x dx, okay? We talked right before that the antiderivative of secant is ln absolute value of secant plus tangent, and we're doing that from 0 to pi over 4. So now I'm saying ln of secant of pi over 4 plus tangent of pi over 4, close that absolute value, minus ln of secant of 0 plus tangent of 0. So we've talked about earlier on in chapter 4 that when that lower limit was 0, that the second half would cancel out. Remember, that's only true for polynomials. Okay, the moment you see a trig function in there, that doesn't apply. Now, on a free response question, we can usually stop at the f of b minus f of a, but because I have trig functions, I do have to continue. So I have ln, absolute value. Secant of pi over 4 is radical 2. And then tangent of pi over 4 is 1. Minus secant of 0 is 1. Plus tangent of 0 is 0. Okay? Now, radical 2 plus 1 is going to stay giving me a positive number, so I don't need those absolute value bars. And then ln of 1 is 0. That is something that you should have memorized. Okay? So my answer is just going to be ln of radical 2 plus 1. Oops, sorry, that should be a parentheses. Now let's talk really quick. If you don't have that memorized, guys, hopefully you at least have your graph memorized. Remember, the graph of ln goes like this, where this is 1 and this is an asymptote. Okay, so remember, ln of 0 or any negative is undefined, and ln of 1 is here at 0. Okay, so whether you memorize it visually or by graph, either works. But know that if you get to this step, you might have a hard time matching it to a multiple choice if you don't remember that concept. Okay, and let's go ahead and look at our last question. It says, find the average value of tangent of x from 0 to pi over 4, okay? Average value is my 1 over b minus a. This is my a, and this is my b. So I'm going to say from pi over 4 minus 0 times the integral from a to b of the function. And don't forget your notation of dx, okay? If you were on a free response question, that right there would probably be a point, okay? So pi over 4 minus 0 is just pi over 4. 1 divided by a fraction, you keep change flip. That's going to be the reciprocal of 4 over pi, okay? Now I'm going to do the antiderivative of tangent. We said was a negative ln, absolute value of cosine of x. We don't need our plus c, and this is going to go from 0 to pi over 4, okay? I'm allowed to take this negative out. It's the coefficient with the 4 over pi. And now I'm going to say ln of absolute value of cosine of pi over 4 minus ln absolute value of cosine of 0, okay? Bring this down. Cosine of pi over 4 is a radical 2 over 2. And because it's positive, I do not need those absolute value bars. Okay? And then cosine of 0 is just 1. So I have ln of 1. And remember, we've said that ln of 1 is just 0. So my final answer is negative 4 over pi ln of radical 2 over 2. There you go.